From the Oregon State University Extension Service, this is Pollination, a podcast that tells the stories of researchers, land managers, and concerned citizens making bold strides to improve the health of pollinators. I'm your host, Dr. Adoni Melathopoulos, Assistant Professor in Pollinator Health in the Department of Horticulture.
I think one of the great stories for 2020 is the remarkable job that Washington State Department of Agriculture has been doing around two issues on pollinator health. The first one we know well, Asian Giant Hornet. And if you've followed some of the outreach but also eradication efforts of the department, they have been exemplary. But also, Washington State Department of Agriculture has been dealing with an introduction of an exotic bumblebee, which is in the north part of the state, kind of in the same area where Asian Giant Hornet is. And I thought this would be a great opportunity when everything's cooled down just a little bit to catch up with one of the smartest people I've encountered, Dr. Chris Looney, who is an entomologist with Washington State Department of Agriculture, where he manages the Olympia entomology laboratory. I think you're really going to enjoy this interview. Dr. Looney has some great insights that you may not have heard of with both of these insects. In addition, gives us a vision forward for what we might expect in 2021 when it comes to both of these invasive insects. So today, without further ado, Dr. Chris Looney on pollination. So last month, we heard from Josh Flash at Oregon Department of Agriculture about the connection between invasive insects and bee health. And Washington has been dealing with some of the same pests as we have in Oregon, but you have two notable problems that we don't have here. The first one, as everybody knows, is Asian Giant Hornet, but the other is more obscure, namely the common eastern bumblebee. Can you briefly recount how both of these insects made their way into Washington?
Well, I can kind of try. We'll start with the big one, literally, Asian Giant Hornet, and we don't really know how that got into Washington State, or into North America for that matter. Our best guess is that, like everything else that comes from across the pond, whichever pond you're looking at, it probably came on cargo. It really only needs an overwintering fecund female to show up and establish a new population. And if you had a big hornet year and a lot of cargo and a bunch of overwintering queens that made it into something that got moved, it's not that unthinkable that they simply sailed across the ocean in a cargo container like so many other species. So that's probably how it got here. Realistically, we'll never know, even with the new research we're conducting this year on population genetics to try and verify really where it exactly came from. The exact pathway will always be a mystery. Bombus impatiens, on the other hand, we are virtually positive that it escaped from captive colonies of bombus used for greenhouse pollination in British Columbia. And we think we're positive because until about 1999 or 2000, I don't quite remember the date, bombus impatiens were not shipped to British Columbia, and they weren't shipped to Washington State, and they weren't shipped to the West Coast in general because the pollinator providers instead sent everybody Bombus occidentalis. As most of your listeners probably know, Bombus occidentalis populations crashed both commercially and in the wild in the late 90s, and there was this sort of crisis in the ability to provide domesticated pollinators. And British Columbia allowed, as did many Western states, not just the province in Canada, British Columbia allowed an emergency use where people could ship pollinators, ship Bombus impatiens, the eastern common bumblebee or common eastern bumblebee, for pollination services for a year or so. And then after that, they simply allowed it to happen. And so there was this influx of Bombus impatiens for the first time on the West Coast right around then. And not much long after, maybe 2003, I think, Kola and Roddy found them flying around in strawberry fields. So that one probably just escaped from a domestic colony.
Okay. All right. So I think many of our listeners are by now familiar with bumblebee life cycle, but true hornets are kind of new to the region. Can you walk us through the biology of Asian Giant Hornet?
Yeah, I sure can. And actually, in a lot of ways, they're not dissimilar to bumblebees. They are a a species that at least in the northern parts of its range, which is where we are, I almost said realm, the royal hornets, in the northern part of its range, they have a colony that is established in the spring by a overwintering female who emerges and successfully finds a place to start a nest, lay some eggs, and grow them up to the first batch of workers. The colony grows throughout the season, foraging in the case of Asian giant hornets for any kind of insect prey they can find. Bumblebees, they'd be foraging for pollen and nectar. The colony gets bigger and bigger at the end of the season. For bumblebee species, it's all over the map. Some of them are early in the season, some are midsummer, some are a little bit late. And for Asian giant hornet, it's pretty much always in the fall, so a very, very late developing colony. They produce a new batch of workers of reproductives, so males and new queens. A lucky few of those will mate. They fly off and hibernate and start the colony cycle all over again. So in broad strokes, it's really the same. A single year social insect colony cycle that begins and ends with queens.
And just picking it up at the beginning of the year. So these queens, they will establish a nest underground, I guess, like some of our yellow jacket species.
Generally speaking, they should be underground. When we were first learning about this species, it's obviously new to us here in Washington State. We read the literature and I think we all fixated on they're in the ground. They're always in the ground. They're in the ground. Turns out 18% of the time they're actually in something other than the ground, like a hollow tree, which is in fact where we finally found a nest in Washington State, which we weren't quite prepared for that eventuality. We were hoping they were going to be in the ground and really, really rarely in maybe a wall or something like that. I mean, we're talking 6 out of thousands of nests reported. So generally speaking, yeah, underground. Although a person in Japan did email me and say, I see these things setting up nests under tarps, like under chunks of wood. Who knows? So they might be a little bit more broad-minded in their nest take, but underground.
So the one thing I was really surprised with, I'm so used to yellow jacket nests, other social wasps sort of starting to collapse in October and November. But the hornet nest that Washington Department of Agriculture eventually found, it was active fairly late in the season. Were you surprised by that, or?
I mean, intellectually, no, because I had read the literature that said, yes, in November, they will disperse their queens. But I think reading about something and then experiencing firsthand are very different. And yeah, honestly, I was pretty taken aback by how late in the season the colonies run and how late in the season that culmination of the next generation of worker production really is. I mean, we're talking well into November. And if you think about it, last year, the first ones that people found were workers that they saw in December in Washington State. So suggesting to me that the nests persisted for a while and they visualized saw the last dregs of the colony out, scampering about the landscape, probably depressed about their impending doom. But they're a late season animal. It's kind of interesting, or maybe not interesting, but that might work to our advantage because it obviously took us a while this year to really get ramped up with our program, figure out what we're doing, better understand what worked, what didn't work. And it turned out we needed every second of that time to finally find a nest of these things. So I'm glad they were late.
You mentioned earlier when we were talking about the life cycle, like bumblebees, the reproductives are produced towards the end of the colony's life cycle. Do we have any sense from the literature in Japan when reproductives start to be produced?
Yeah, it's like mid-October or after that. Okay. For northern areas. So I could go back and look it up specifically. There is a great series of papers by Dr. Matsuura in the 70s and 80s that really document in great detail. I think they are the most detailed available studies, these nest cycles and stuff like that. And they're quite explicit about when males and females start showing up, or males and queens start showing up. But late October.
One of the concerns with Asian giant hornet is its impact on beekeeping. And I realized looking through some of that Japanese literature that the predation isn't all the way through the season. It happens really in the fall. Is that right?
Kind of. Predation can happen earlier in the summer, but in that case, it's the loss of an individual bee here or there. So nothing nothing much different than normal yellowjack predation or a bird or a car driving on the road. So, but the dramatic group attacks that can very quickly decimate an entire colony, yes, those are distinctly a late season phenomenon, like into September or later.
And what can you describe what that kind? I understand that this can be very quick. So in a matter of an afternoon or a morning, a colony can be taken down. What do you know about how this kind of phase of depopulation of a bee colony looks like?
So again, all my experience is based on reading and rereading and rereading. 105 minutes is in fact the average amount of time it takes a couple of dozen hornet workers to destroy it. So yeah, you could, this is a point I keep making. You could be a beekeeper. You could work your bees in the morning. You could go to lunch and you could come back to a nest or a hive full of hornets instead. So it could be that fast. And so what happens is, and this is associated with that ramp up into the season production of reproductives. So you can imagine that the colony is just really searching for the most amount of protein it can easily forage for on the landscape at that time of year. But a hornet will mark a hive with a pheromone, and that helps recruit her sister warrior soldiers, and they come and essentially just kill bees. If they were to catch a bee earlier in the season, they would catch one, bite its head off, kind of mash it up into a ball of food and take it back and feed it to the babies, just like they would do a katydid or a beetle or anything else they would find. When they do these mass attacks late in the season, they instead just catch the worker bees. Essentially, they behead them, throw them to the floor, throw them to the ground, and move on to the next one. And they just do that with wild abandon until the bees can't really mount any kind of defense. And then they have this unmonitored grocery store. They can just wander around in the hive at will, plucking pupae and larvae out, which I think we all know are very tasty, like land shrimp, and take them back and feed them to their babies.
Sounds brutal, delicious, and all sorts of things.
So that would be a real bummer.
So, but I guess the detection of a nest was not from one of these mass attacks of a honeybee colony, but it was a landowner. Tell us a little bit about that situation where you guys were able to locate a nest, find it, and kill it.
Sure. From the very beginning, our survey approach had multiple sort of facets or multiple prongs. One were the kind of traps that we put out as an agency, not dissimilar to a gypsy moth trapping program or any other kind of exotic pest program a Department of Ag might deploy. We also recruited people. We called it our citizen science program, and asked them if they would be willing to just hang the same kind of trap that we were using at their house and report back the contents to us. This is based off of sort of public science projects in Japan, where people have been really effective at both monitoring and reducing hornet density. And it's also kind of a recognition of the fact that we weren't quite sure how wide of a net to cast. And if we could get people to help us, well, it's just more eyes, and in this case, traps on the ground. And the third one was actually eyes on the ground. We had a bunch of different approaches to try and encourage people to submit sightings to us. One was a web page. We also had a dedicated phone line and dedicated email address. And the web page turned out to be really useful. Granted, we had over 7,800 submissions from all across the world, 4,500 in just Washington State and BC. All of them but 20 were totally something else. Yellow jackets, Mormon crickets, dog vomit, something that wasn't an Asian giant hornet. But one of them, 20 of them, turned out to be bona fide or really likely hornet sightings. And one of the later ones was a landowner who caught two and said, "Hey, I think these are your thing." And that was in a place that we weren't really trapping heavily. And honestly, if he hadn't found those and posted them, we may never have found that nest. So what happened is he posted them. I went up and hung out with him. It was a really great guy. We ended up catching a hornet together and used that for our first failed tracking effort. He caught one a few days later. We tried it again. By this time, we'd saturated that area with traps, including some experimental traps that Dr. Jackie Serrano at USDA and I were running, and those caught more hornets. And that's what we were able to finally attach a radio transmitter to and follow it back to its nest. Wouldn't have happened, though, if he hadn't reported those hornets.
That's fantastic. And I do want to circle back. I think Washington State Department of Agriculture did really I was amazed at the social outreach. It was fantastic. It's really a textbook example of how to engage the public on an invasive insect. But before we do that, so let me get this straight. You had to get the radio transmitter on. I guess the idea is that if you have to find the nest, it could be anywhere, but if you had a radio transmitter on the Hornet, then you could track it back to the nest and be able to locate it. But you mentioned that use traps to to collect these hornets without killing them. Can you tell us a little bit about that? That's really intriguing.
Yeah. So again, all along we had this idea that we weren't quite sure how to find this thing most effectively. So we would have these kill traps that we put everywhere. That's what the dominant trap approach we had and what the citizen science traps were. And those were a mixture of orange juice and rice wine. We picked those things because the literature proves they work. They're just one of a whole slew of candidates of things that also would have worked. The ethanol is to deter pollinators, the orange juice is to attract the wasps. And those were essentially a drowning solution, right? So if you're a wasp that gets in there investigating this mimosa, you die. Mm-hmm. Once we had some evidence that there were lots of hornets active in an area, and in this case, we had that landowner's submission, 2 other people's eyewitness accounts, and then when we put some traps out, we started catching them. So we knew that they were there in the area. We deployed these live traps, and we had kind of 2 models of live traps. One of them turned out to be a complete bust, and that was essentially one of our mimosa traps with a screen at the bottom so they couldn't drown. They also could just walk right back out of the trap. So that turned out to be a fail. The other ones were unit traps. They're these traps that people use to survey for moths and stuff in fields all the time. And they have sort of this inverted cone. The wasps go in the top, and then they have a really, really difficult time getting back out. And that's actually what ended up being useful. We caught some live hornets in these traps. So they had the same thing, a screen to prevent them from getting to the bait and drowning. I put some jelly in there to give them something to eat if they showed up and were hungry.
Oh, right, because you needed them to fly back.
yeah, right. We just need them not to be all worn out. Actually, the one we ended up tracking back wasn't in one of our live traps at all. We had 4 live wasps to work with on the day that we were successful. And 2 of them had gotten into one of our experimental traps early in the morning. And that was just a boric acid solution. So this like mellow water solution. And they were in there kind of like backstroking around this liquid. And we pulled them out, dried them off, fed them some jelly. And those turned out to be the most robust of the 4 hornets we had available. So, but that was pure serendipity.
Fantastic. And so, yeah, and then we all saw, it was all over the news. It was like, a huge international news event. You guys went out in your crazy, it reminds me of one of those cartoon characters in the Pixel movies, the suits that you had.
Somebody bleached the minions.
Exactly.
We made what do they call it? Mock the Week. It's like a BBC show where they have kind of like Wait Don't Tell Me, where they make fun of new stuff, and we were on there, and that was what they said, that we looked like bleached minions from Dastardly Me, whatever it is. Despicable Me. Despicable Me. Yeah.
That's right. Okay, so you guys went out there in these crazy suits, and how did you kill the colony? You used carbon dioxide, I believe, or?
Well, actually, no. We did use it, but it wasn't to kill the colony. And this is another thing we kind of went round and around about for a while. Our initial thought was we would use an insecticidal dust. I don't remember what the active ingredient is, but basically it's the kind of pole dusting applications that people use to kill aerial yellow jackets. But I also knew that we really wanted to look in the nest. We wanted to spend some time seeing if we could learn anything from it. And then we didn't want to leave behind contaminated soil. And so I actually hung out with the guys from Cascadia Venom Collections. I can't quite remember the name. They're local here, and they catch yellow jackets alive and sell them back to pharmaceutical companies. They just vacuum the things up. So, the Hornets, in a lot of ways, just a really, really big yellow jacket. So if it works for that, it should work for this. And so that's what we ended up doing. We vacuumed them up using a shop vac. They were collected in this cylinder, and then we were able to cap the cylinder and throw it on ice. Then we had all these living hornets that we were able to weigh, and that's how I could figure out that they didn't work in our live traps, because I ran them through a whole bunch of different trap types, and within 15 minutes, they crawled out of all of them except for one. So that's good. It gives us more power going to next year. We were able to provide some to a researcher, Dr. Jackie Serrano, who was able to use living hornets for some like sort of selection experiments to see what they're attracted to. But yeah, we just vacuumed it up. The carbon dioxide was simply there to anesthetize them.
I gotcha.
When we were starting or when we were finishing, because we vacuumed them a bunch up, but we knew there were still some wasps in there. And so then we flooded it with carbon dioxide so they wouldn't come swarming out at us while we sealed it with foam. When I say it, I'm talking about this nest in a tree. Yeah.
I realized, when this all occurred that we really don't have a good social wasp person. We had Megan Ash on a previous episode, and we heard about it, the passing of her supervisor, but we really don't have a good social wasp person in the Pacific Northwest region.
We don't right now. I mean, with Acre gone, and that was quite a while ago, and now Pete Landell gone. Megan's sort of the, she's the next vanguard, I guess, for social Hymenoptera that aren't bees, unless somebody else pops up anytime soon. So hopefully this does not provide the impetus to do that. If we end up with an established colony or population of Vespa mandarinia up here, the Pacific Northwest may very well need a social Hymenoptera specialist or a social wasp specialist.
Well, yeah, I suppose. Let's come. The one thing I was so impressed with is, and we all were, was the department's ability to respond. I was astounded. The media posts did not look like a typical invasive insect campaign. They were humorous. They were direct. They were focused. Tell us a little bit about how the department was able to work so quickly and get such great messaging out.
Part of it is because we have happened to hire a couple of really great people that do that kind of stuff over the last few years. Specifically, I think it started with gypsy moth. When we do gypsy moth eradication events, we are spraying pesticide. Granted, it's BT, so it's a pesticide that's really innocuous for almost all living organisms. But still, you're spraying an enormous amount of people and their property with a pesticide, and the optics of that and the messaging of that can be really, really tricky. And so we are lucky to have this woman, Carla Sulp, on our staff who is good at that kind of stuff. And so she came into this with a very, very ambitious approach and a very approachable style in that approach. And she really led a lot of that outreach effort. And then we also hired Cassie Keyhorts, sorry. Her name's spelled exactly the opposite of the way I want to say it. Who was able to pick up a lot of the slack for for all the outreach presentations people have been asking us to give and stuff like that. So some of it's just trying to be honest and natural, and some of it's benefiting from a person who is good at thinking outside of the bureaucracy.
Mm-hmm. That's clear, actually. It's at the end of the year, I was looking at the Facebook page. There's almost like a community in Washington of Asian Giant Hornet, looker-outers.
Yeah, I gotta think that's partially probably because of the honeybee impact. If these, I don't know, it's something that wasn't a charismatic insect, right? If they fed on ground beetles, I don't know that we would have a couple of beetle nerds who are really enthusiastic about this, but it wouldn't be everybody, right?
In the midst of this, I'm always impressed that you're able to do this. But in the midst of it, you released a paper forecasting the spread of Asian Giant Hornet, really timely, and a lot of people, I think, really welcomed that. Can you go over the findings and what are some of the scenarios for the Hornets? What's kind of like the realm of possibility of expansion of the Hornets range in 2021?
Okay, so a couple of things. First of all, I take like really low billing in that. It was mostly postdocs out of Dave Crowder's lab at WSU. So it really was their model, not mine. And also two other labs have now published similar studies. There was one that was published out of Brazil just a few weeks or even a few days before this study was accepted. And then the University of Kansas, there's a research team that has a paper that should be out now in PeerJ. So not my work. I helped, but I was coattailing on that one. So the main implication, and this is where all the papers agree, is that there is plenty of available habitat, at least bioclimatically, in the Pacific Northwest. And then if the hornet should be able to hitch a ride to the East Coast, even more there. So there is no reason to think right now that there's anything about where we live and work that this hornet will find unpalatable in terms of its ability to survive. So we're fine habitat. And then the other take-home message that, again, I think all three studies or all three papers kind of came to the same conclusion on is that if nothing impacts this hornet's biology in a way that's unique to here, or if there aren't any impacts of bottleneck effects or early population effects or something like that, there's a lot of potential for the animal to spread very, very rapidly. And then this was a dubious aspect of all of the papers because nobody actually knows how far queens disperse. Nobody knows what their dispersal behavior is. And so I guess those are the two critical factors we don't know anything about. So instead, we modeled it off of Vespa velutina, the Asian hornet, which is invading Europe right now, where it's spreading like 78 kilometers a year. So this is a very, very rapidly moving insect. We don't know if this one would be as rapid, but we have no reason to think that it wouldn't be. So I guess the take-home message for both is that if nothing keeps it from establishing, it's probably going to do just fine. And it's going to be in Oregon within a decade or two.
Okay.
Probably two. Yeah.
What about as we get over the Cascades into the what's the model predicting?
Yeah. So again, all the models sort of predict similar stuff that once you get into the drier and more harsh winter areas, the two together, that the habitat really suitability drops off. So east of the Cascades, at least in the Columbia Basin, it looks pretty poor. Maybe once you get up into the forest again around the Panhandle and adjacent Washington, it's okay. But east of the Cascades, south into eastern Oregon and into Nevada and Colorado, all of that stuff should be hornet free. And then, of course, the Great Plains also look to be really unsuitable habitat. So there's this band of great habitat from Haida Gwaii all the way down to like the Bay Area, and then nothing, maybe a little pocket in North Idaho, and then nothing in the Midwest and central Canada, the prairie provinces and the plain states, nothing. And then once you get to the East Coast, once you clear that stuff, great habitat again.
Okay. And I guess the last question before we move on to bombus impatiens, what are the prospects for eradication at this point? I'm sure there's a heavily debated question as to whether eradication is possible or not, but what are some of the thoughts on eradication at this point?
Well, I don't know. It's heavily debated. I think everybody agrees that the probabilities are low.
Okay.
And low because we have poorly developed tools. If this were gypsy moth, we would have already eradicated it. And that's because with gypsy moth, we have a trap that will draw in males at incredibly low densities for quite a distance. We just have these irresistible monitoring tools. For the hornet, again, we're hanging cocktails in trees. That is competing with everything else that's attractive to it in the place where it lives. And so our ability to monitor and detect is sort of weak. And that's our Achilles heel for this. If we had better detection tools, then I think eradication is great because the biology of the animal really lends itself to getting a lot of work done by us in the middle of the summer and early fall. I mean, if we can find colonies before the end of October, we've basically, kept them from reproducing. It's not like something where every female goes out and reproduces. So we're aided by some of the features of this animal's biology, but we're at a real disadvantage because it's hard for us to trap it and detect it on the landscape. So that's another reason why we have to really we have to have as much public outreach as possible. Those eyes make up a lot of ground for bad traps.
Okay, fantastic. Terrible news story for 2020, I guess also 2019. We had Katie Buckley on a recent episode, and she described that the Pollinator Health Task Force in Washington sort of convened its first meeting the day after the discovery. It's been a tough year in Washington. You guys are doing a great job, though.
Yeah, we got a lot of things to think about up here.
Well, let's take a quick break and let's turn our attention to this other invader from the north, bombus impatiens. Okay, we're back. So under the nose of most of the public, you guys have also been contending with an aggressive spread of bumblebee. What's the current range of the common eastern bumblebee in Washington? Do we know?
That we don't know, but we do know that it's made it at least as far as Bellingham. And then there's an isolated record in Island County on Whidbey Island, and then another isolated record from this summer in Discovery Park in Seattle. So the Discovery Park record was collected by a bumblebee researcher, and she returned to that site over and over and again and never found another bee. So, who knows where that came from. But we know it's well established in Whatcom County, at least as far as Bellingham.
Now, I remember hearing a couple of years ago that you had already employed people to help track this bumblebee. Tell us a little bit about that program of getting the public to help the agency in tracking this bumblebee.
Yeah, it's similar in the idea to the Hornet in that, like, we're trying to make up for things we lack. In this case, the thing we lacked was any kind of money whatsoever to look at bombus impatiens. But we do have an active network of master gardeners who are obviously very engaged in taking care of their environment, both near and far. And knowing that we would be seeking funding, but not wanting to let time and data pass us by, we reached out to the master gardener coordinators for San Juan County. So that's the San Juan Islands between Vancouver Island and the mainland Washington State. And then Whatcom County, the same place, currently hosting Asian Giant Hornets, to see if those master gardeners would be willing to hang out just the blue vein traps that people use for monitoring. And by putting those out, we might be able to start creating some preliminary data, at least, and then maybe even track its spread as it was going. And so we did that for 2 years. We did not have time to do it at all this year. Nobody got into it. And the 2 years we did, none of the master gardeners found any bombus impatiens, which is sort of interesting. So.
Oh, that's reassuring at the same time.
Well, kind of. It could also be a bit of luck of the draw. We do know that we're getting them in our Japanese beetle traps. And again, I have an entire year's worth of traps that we haven't looked at. I think those will provide some pretty cool distribution data. And we're catching quite a lot in our Asian Giant Hornet traps. Actually, we've caught, I just pulled it up, like 100 and something bombus impatiens in Asian Giant Hornet traps so far this year. So again, I haven't had a chance to look at the geographic spread of that, but if they're abundant enough to blunder into these traps which do not seem to attract bees, by the way, I find that, well, frankly, worrisome. Or they're alcoholics and they were going for those really bad mimosas. It's hard to say.
I guess the question that some of our listeners have is, why is this an issue? It's a bumblebee and bumblebees are good. So what might be the problem with the spread of this bumblebee?
No, it's a really fair question. And the two problems that come to mind are, one, it disrupts the existing bumblebee colonies, which may or may not have negative impacts on anything other than those bumblebees, but we simply don't know. And then there's always the potential to move disease and pathogens around, which would, again, sort of impact those colonies or those native bumblebee communities, but in ways we can't anticipate. And the reason we're concerned about this is what we know about bumblebee introductions historically. And I'm just going to talk about the two bumblebee introductions that have occurred, or the two geographic areas where bumblebees have been introduced where other bumblebees already lived, right? So we have bumblebees introduced into New Zealand, but there's no bumblebees there. So, it's a very different system. Bumblebees were introduced in Japan, these same kind of commercially used bumblebees. I think it was terrestris and one other one, European species that are commonly cultivated for pollination, just like impatiens and occidentalis before it were. Introduced in Japan, escaped and became really common in the northern islands. And initially, it seemed like there was a lot of maybe displacing some species, competing for nest resources for a few species, and even mating interference. So lots of hybridization that led to non-viable offspring. But when you have large colonies that are doing that, they're not impacted as much by that as colonies that tend to be small. So there was a lot of concern that these impacts were negative, but that seems to have kind of tapered off. Like the effects might be more ambiguous and really species specific, because you've introduced a bumblebee into a place with lots of thriving congeners, right, who have presumably co-evolved and have been dealing with other bumblebees for as long as they can remember in their evolutionary history. The other place bumblebees have been introduced where bumblebees exist was into Chile and Argentina. So again, terrestris, and the other one, I cannot remember its name, escaped probably from cultivation and have become established in the wild in Patagonia. And there they are absolutely displacing the largest bumblebee on Earth, Bombus dalbamii, described as like a flying mouse. It's this enormous, beautiful, crazy, like megafauna of a bee. And it's where its range overlaps with these introduced species, it is just summarily being pushed out. It is being outcompeted for floral resources, and its range is shrinking dramatically. So what we have in the Pacific Northwest is a situation that seems wide open. Will it be more like Japan, which seems to make sense because we have a lot of bumblebees here already? Will some of the bumblebees succumb to competition and suddenly find that they don't have a place in this landscape anymore because they're being outcompeted by Bombus impatiens, and it's coming into a place that's already been disrupted by the loss of a really common pollinator, Bombus occidentalis. Used to be maybe the third most common bumblebee in Cascadia. I have seen it one time in the wild in my 15 years of working here. So that left a void that may or may not have been filled by Vosnesenskii and may or may not now be being filled by Bombus impatiens. The answer is we don't know. We can't put this genie back in the bottle, right? We can't put the Bombus back in the colony. It is here to stay, but we might be able to learn something about its impacts and use those to make more informed decisions about how we regulate pollinator movement. It may turn out that we don't have to worry about it. It may turn out that this is a horrible idea, and we're in a place to maybe learn something about that.
I think that's great. I think, the genie is sort of halfway in the bottle, halfway out, and it gives an opportunity to see what it would look like in real time, because you have large parts of the state where it's not present. And, I think that's a fantastic opportunity to study this problem before it's kind of moved through.
Yeah. I mean, we've sort of ended up with a natural experiment, right? Where we get to set up a before and after, that was part of the impetus for working with master gardeners to collect some preliminary data to see if we could come up with some ground level background data, I guess, that we could measure community change against, which, may or may not happen. We'll see. I will say that bee seems to have spread very, very quickly and become very abundant in the places where it is established in the north, so much so that it's now in like field guides for the city of Vancouver. It's the bee you'll see all the time. And I went to a community garden in Blaine last year at the end of the year, and it was easily 80% of all the bumblebees I saw. But just a few miles south, I didn't see a single one. So there is, there's this, it's a population that's definitely moving, but hasn't yet become entrenched everywhere.
Okay, well, we'll keep our eye on that as well. Let's take a quick break. Our last segment is we've got 3 questions we want to ask you. Well, recommendations for our listeners. It's a surprise. You'll love it. But we'll be back in just 1 second. Okay, we're back. So 3 things. The first thing we ask you is we just at the break, Chris kind of meticulously went through his books, and I'm going to have him do it again. So 3 books you've got to recommend. Give us the 3.
It turns out I don't read.
They're right in front of you. I can see them.
I was saying that I'm one of those people that ineffectively reads multiple books at a time. It takes forever to get through them. And there's probably something psychological in there. One book that I'm reading right now is the book Seeds by Tor Hansen. He's an author based in the Pacific Northwest, science writer. He's also written a book about bees and one about feathers and one about mountain gorillas in Rwanda. They're really, really nice. He has I think, a good voice, a good narrative style. And he brings science, I think, makes it available to just about anybody. My wife loves the Seeds book, and she has never even taken a science class as far as I know. This other one that I'm reading right now, I'm sort of rereading. It's called A Natural History of Western Trees by Donald Peaty. It was written in the 50s, and it's just a series of sort of narrative vignettes about different tree species. And so that one's great because you can just pick it up, read a chapter about whatever, Western aspen or white pine, finish the chapter, drop it, and it doesn't matter where I open the book next time because they don't build on each other. Whatever happens to the aspens doesn't influence what happens to the white pines. And so that one's great. I like it. And then my fiction fun book I'm reading right now is a book, and I don't even remember the name of it. It's something on the Kindle by a woman named Cage Baker, recently died, who writes, she has a series of books about these cyborgs. Well, so it's a company in the future who's mastered the art of, or the science of time travel, but they can't actually stay in the future. Apparently it makes them sick, or the past makes them sick. So instead they go into the past, find orphans that would be abandoned and killed probably, and they basically turn them into these cyborgs with nanobots and stuff. They train them to be specialists in something. So they might be an art historian or a botanist. That was the character that I first read about that I thought was so interesting. And essentially these people move through time and find stuff that's valuable that's in the shadows of history, where there's no documented story about what happened to it. And they bring it to the future, and then this company gets to sell it and make a lot of money. So, I mean, there's more to it. There's like all the kind of soap opera sort of stuff and a story arc that transcends multiple novels, but it's pretty fun, and it's got scientists in it. So like
time traveling cyborg scientists. Yeah. Wow. Yeah, okay.
Botanists on top of it.
Botanists. Fantastic. Those are great. Those are all really great suggestions. And I do remember, I think I had that tree book at one time and remember doing exactly the same thing, just flipping open to a page and just seeing what was going on there.
Yeah, I think it's been republished recently too, but I don't know, it probably didn't change anything, but there's a new edition out. So.
Okay, our next question for you is, do you have a go-to tool if you're on a desert island you find indispensable for the kind of work that you do?
Well, that's you're going to have to ask a new question, because the kind of work I do is whatever bug drops into my lap that month for the Department of Agriculture. So no.
I need the whole infrastructure.
So we live in a lot of ways in a glorious time, right, where we have the power of written monographs at our fingers like we've always had them, plus this, preponderance of, or not preponderance, but just this glut of high quality visual images that then take these obscure writings and turn it into something that we can recognize as a visual predator, plus digital keys like Lucid Keys, plus experts that we can email. I mean, I can't imagine doing the work I do now and being halfway as good at it if I had to go back 30 years even. Maybe it wouldn't matter. Maybe everything gets reset. But the reality is I live in this information ecosystem that encompasses every kind of medium you can imagine. And I get to stand on the shoulders of 70,000 giants instead of the 3 or 4 whose books I can afford. So I don't know.
Great answer. I reject the premise of your question. Awesome.
Sort of. Yeah.
Okay. Last question is you run into a lot of critters. Do you have a favorite pollinator species?
I have a favorite pollinator species? I don't think I have a favorite any kind of species. I'm not batting anything with your questions here today.
No, you're batting them in your own way.
I mean, no, I don't have time I don't play favorites, man.
There you go. Awesome.
They're all so darn interesting. I will say that I have an unfavorite. It's something I avoided all the way as an undergraduate and all the way through graduate school, and that was social stinging wasps. And now it's the only thing that I've thought about since May. There is some irony, schadenfreude, all of that good stuff for you.
It's one of the circles of hell in Dante's Inferno. It's like the social wasps.
Followed by earwigs and anything that feeds on corn. I'm just like, I don't want that.
Well, thanks for being so generous with your time. Really appreciate it. And keep up the great work you're doing up there in Washington.
Thanks for the kind words, and ditto in Oregon, man.
Thank you so much for listening. The show is produced by Quinn, Sin, and Neil, who's a student here at OSU in the New Media Communications program, and the show wouldn't even be possible without the support of the Oregon Legislature, the Foundation for Food and Agricultural Research, and Western SARE. Show notes with links mentioned on each episode are available on the website, which is at pollination.podcast.oregonstate.edu. I also love hearing from you, and there's several ways to connect with me. The first one is you can visit the website and leave an episode-specific comment. You can suggest a future guest or topic, or ask a question that could be featured in a future episode. But you can do the same things on Twitter, Instagram, or Facebook by visiting the Oregon Bee Project. Thanks so much for listening, and see you next week.